Hi, everybody. As I think about concepts in teaching, I haven't had a specific computer science class, but having taught algebra, algebra 2, and things of that nature over the years, the first concept that came to my mind was isolating the variable or solving for the variable within any given problem. And while students, for the most part, didn't struggle mightily with that when it was linear equations, x plus whatever number can equal something else, or even if you're getting into the double variables with y equals mx plus b, slope of a line, and things like that. They didn't have a lot of problems isolating variables or solving from that perspective. But when you get into quadratics, once you have that, x squared plus 10x plus 16 kind of thing, students started to have more issues in understanding that those same concepts, those same ideas of isolating the variable can exist within there, especially as you start to go towards like factoring or things of that nature. I mean, it's easy for a student to do x squared equals 25 and then just take the square root of both sides. But once you go into processes and things of that nature, or more complicated ones that can use other processes, I should say, they wanted to focus more on those processes and those steps. How do I factor? How do I complete the square? How do I graph the quadratic? And all of those things can be laid out in steps as well, which I think lends itself to the students just wanting to know, how do I get through this problem and complete this piece, and as opposed to understanding the underlying concepts behind that, so that I can do it when I see other either more complicated or different versions of the problem, which is the easiest way I think as a teacher to attack that a little bit as well with students, because not every quadratic can be factored. And while you can graph them all, they're not always going to give you a pretty answer on there without the use of a calculator anyway to know the exact, let's say, decimal or square root answer that you might get, particularly when you start to get to the imaginary ones as well. Obviously, that's not going to work with the graphing side. And while you can always do completing the square and some other, or some other processes in and around those quadratics, you can present problems to students that they need to understand the concept of isolating that variable and getting that by itself, and the purpose behind doing that before they go through all the small steps. And all that's built in that early Algebra 1 and pre-algebra and things of that nature, where you're isolating the variable to figure out what it represents. But once they hit those quadratics, like I said, they just kind of want to know, what are the steps? Where do I go from here? And I think that's the primary reason behind it from the students, is they want to complete the problem. They want to finish. They want to get done. A lot of them want to do it right, and they want to be correct in what they're doing. But the goal is for many of them is to get done, as opposed to understand. And I think that's at the heart of every concept teaching that goes on. I think it lends itself particularly to math and probably some computer science as well, and some other courses. I think of social studies and history and stuff, just kind of wanting to know an answer, wanting to know a date, wanting to know something of that nature, versus trying to understand the underlying concept, which then can lead to an understanding of different problems that you haven't seen yet, things that may come up, whether it be in tests or future classes or things of that nature, which is probably the primary means of handling as a teacher, is to present problems from a math perspective, again anyway, present problems that don't fit the mold, so they have to understand the concepts and the ideas behind it, versus knowing a specific set of step-by-step directions to get them there. And when you do that, when you can get them thinking outside the box, when you can get them thinking of what is my overall goal here versus follow step 1, 2, 3, 4, then they can really start to understand that concept. They can really start to understand the reasons behind doing something, and can then implement that for other issues, problems, or things that may arise for them in the future in that class or in other classes as well. That's been my experience with math. Obviously, like I said before in my intro thing, I've been in counseling for a few years now as well. So it's been a couple years since I've dealt with that specifically with students in there. But I remember Algebra 1 specifically, as you get to those quadratics, running into a lot of them not remembering the basic concepts, not connecting the concept of isolating the variable to the quadratic section.